Hey, this is our submission for Group 1 IR for Exercise Explore Computer Vision Fall 2020 at CSU East Bay with Professor Dr. Lynn Grew. I just want to run through the exercise that we completed locally. So we chose to do LSTM example video activity recognition, which takes a directory of a whole bunch of videos, extracts frames from those videos, extracts features from those frames, and runs them through an LSTM network to do predictions to see what kind of video, essentially what kind of activity is happening in the video. So just running through the steps real quick, we have our imports here. I use TensorFlow version 2.3.0 because that's what I had. Defining some paths, frame generator, making our data set, using our model, extracting features. You can see it was 33,295 iterations, took about almost 8 hours. There was an issue with this, which I'll get to in a second. There was one video for some reason was missed in this process, and I had to manually redo it for that video. But anyway, our labels are made here. You can see all the different types of activities we have. The model is created, compiled with these parameters. Test files pulled down from Lynn's website. You can see the test list is here. Separating train and validation data sets in batches of 16. In this step, I actually went back, and this was me fixing the one broken video that wasn't processed for some reason. It was only one of them. So this is just a quick cell that is pretty much just a copy of a lot of the code above, but just for that single file. And it does properly replace the one, you can see here, 40 iterations, the one bad video path that was failing was replaced here. Training was done here. I opted for 10 epochs instead of 17, figuring that'd be good enough, and looking at our accuracy, it seems fine. You can see the training for all the different epochs here. Didn't take too long, I don't believe. You can see the accuracy increasing, getting around 90% accuracy after 10 epochs. Summary of the model. I saved the model, which I can go ahead and navigate over so you can see that directory structure. So you see the saved model. We have a H5 model here, and TF Lite model here from this cell, which is now supported, it looks like, because the model was exported. Did some evaluation here. You can see test loss, test accuracy. Test accuracy is not horrible, I think. Let's see, 69% accuracy. Top K categorical accuracy is 90%. That makes sense. There's some of those are kind of similar, like basketball versus basketball dunk or something. There's some that are pretty similar, so we can see why top K would be better than regular accuracy. And then we did some predictions. You can see predictions shape tensor, reloading the H5 model, printing the model summary, again, saved model. You can see that again here, saved model directory with everything properly saved. We did prediction on a single video clip. So I chose one of a video of someone taking a basketball dunk, and that was of class 8. We can go ahead and look at data. 0, 1, 2, 3, 4, 5, 6, 7, 8 was a basketball dunk. And after running predictions and inference on that one image, we did feature extraction, all the pre-processing stuff. Here we go, prediction, model predict, and then we print the predictions, and we can see for every frame, all 40 frames extracted, the correct class was predicted of 8. which as we saw was the basketball dunk to show that this was fully functional. And just again, looking at the directory structure of the notebook, the test video, the train log. Oh, that reminds me, TensorBoard. So TensorBoard I ran on the command line. You can see the command here to run TensorBoard log dir at the current working directory, which is the train log, and that is visible here. You can see as we increase epochs up to 10, our accuracy increases, training accuracy, validation accuracy, whereas our training and validation loss actually seem to increase after epoch 4, which suggests that there was actually some overtraining doing 17 epochs, and that perhaps just looking at this, it looks like 4 or 5 epochs was actually, in our case, the optimal position. It looks like it did actually overtrain on the training data, which is interesting. I didn't notice that. Yeah, it's a good thing we didn't train a 17 because it looks like optimal was around 4 or 5 in this case. And that is the exercise.